Hi friends, let's continue our discussion on internal developer platform. So in last video we discussed about how DevOps works and how we can relate that with internal developer platform. Today we are going to see more about internal developer platform architecture itself. So an internal developer platform consists about a UI or CLI, graphical user interface or CLI, which talks to a control plane, and this control plane talks to a Git, and control plane deploys to AWS, Azure, your GCP, which also manage your database and compute resources. So here, control plane also have control on your pipelines. Okay, if you see this architecture, more or less, a developer have access to a UI or CLI and also access to your code. But rest of this are taken care something called control plane. And what this control plane is, you want to deploy to AWS, you can deploy. You want to deploy to Azure, you can deploy. Once you deploy in AWS, what you will be running in AWS, a compute or a database services. Those are also managed by this control plane. So let's look into to understand this control plane concept. It's not pretty new. It is long way. So where we were using this concept in Kubernetes. So Kubernetes already works in this way. The Kubernetes has some kind of universal API, which we call it as kubectl. So for whoever is working on Kubernetes, you use kubectl get pods or kubectl get containers or namespaces, whatever it is, right? So what is get means? When there is a API, you are getting this using a kube control. So it's a kube control. What does it mean? It is talking to the control plane. In Kubernetes architecture, we have something called API server, controller, scheduler, and then we have something called etcd. So primarily, someone is working on Kubernetes. They know about these things, but of course, Kubernetes comes with something called master server and worker nodes or master slave, whatever it is. So it is a cluster. Kubernetes is a cluster where your resources are running in different nodes, node 1, node 2, node 3, where the pods are nothing. Inside the pods, you have a container. And all these are managed by this master server. What the master has? Master has a API server to talk to all these resources. Controller control these deployments over these different nodes. Scheduler who go and checks. For example, if this node is failed, all the pods running in this node will move to another node. So scheduler will take care of it. etcd is your configuration database. So if this node is died and when things are moving to this node, where those details are, the image details are, it's in etcd. Etcd is a database. And in a real scenario, we will have two master also, but let's not go into detail. So right now you think about you are managing Kubernetes or Kubernetes is like organized in a cluster way where there is a control plane or a master plane. That control plane is managing all the worker nodes. Inside the nodes you have your applications, and if you want to deploy you will say kubectl minus f apply. If you have an application you will have a deployment file deployment.yaml, and deployment.yaml will have the name of your application will be test one. So now when you apply this deployment.yaml, there will be a test one application will be run. Of course this this also will have a docker file and build and such thing, but it's just an example how you are deploying into Kubernetes. Now Kubernetes is available in AWS called EKS. In Azure, it is AKS. In GCP is Google Kubernetes Engine, where you can run Kubernetes, or you can also have your own on-premises Kubernetes. Okay. So in Kubernetes, everything works good. You mostly you have their own set of tools. For example, Argo CD. You have a Git, Argo CD, or Flex. Okay, I will come to these tools, Flex, and then Kubernetes has a variety of plugins where we used to manage. But most commonly used deployment tools are Argo CD and Flex and Flex. Okay, Flex. Flex is actually a CLI based. Argo CD has UI, uh, but those are the deployment tools for Kubernetes. So here you see when there is a node failed, this control plane move all the resources to another node. And you can also have auto scaling. We call it as replica sets in Kubernetes, where maximum minimum is one, maximum is three nodes. Or like when there's a high load in your pod will get more resources, two, three pods, four pods, five pods to serve the traffic. How that is happening, even though we declared in the configuration in the deployment.yaml what is the max and min. So any changes to this YAML file will reflect in your Kubernetes cluster. So we will apply this to Kubernetes, and Kubernetes understands this control plane, understands this configuration. When we say kubectl, you are calling this API server, and you are giving get or whatever operation apply. You are applying to this API server. This API server this control plane scheduler then passes the information to your nodes. So now let's think about I don't want to use Kubernetes. I am moving away from Kubernetes. I am deploying in other services like Lambda or ECS. In the Azure, I am using Azure Container Service. Okay, then how this control plane is designed? There it comes. Okay, let's have this Kubernetes. On top of Kubernetes, let's ask Kubernetes control plane because Kubernetes I have an API server, universal API, which I described here, and it has controller and scheduler, okay, etcd. So there is a plugin called Crossplane. So we are installing something called Crossplane. What this Crossplane does, Crossplane has different providers. It has providers as AWS, Azure, Terraform. Okay, so basically providers. So for Kubernetes, we use custom resource definition, XRD. Okay, they call it. Same way for crossplane, we have something called composition. So this can be written in YAML, Python, or Go. It's your preferred language, but let's keep it YAML for simple. For deploying anything to Kubernetes, we use YAML files. For pipeline, so same way, uh, we will have a YAML file with the provider AWS to ask him to deploy. So now this Kubernetes control plane will deploy to AWS, understanding with the help of Crossplane. So think Crossplane is an add-on or plugin to Kubernetes to provide these providers for other resources. Now, whenever we deploy a component, it will for Lambda. Now, Lambda will be deployed in AWS, but Crossplane will talk to API server, and Kubernetes will create a pod, and in the pod will initiate this Lambda. And if you try to delete the Lambda, it will recreate because the control plane still refer to this composition and it will create. So how Kubernetes is working, same way we will make everything to work. Okay, so in IDP we we are solving this control plane part. How we will bring this control plane, and one of the example is cross plane. Why we bring in cross plane here? Because if we want to manage this IDP in Kubernetes, it is fine because Kubernetes itself the architecture of control plane. But now since we want to have multi-cloud deployment, then we are talking about cross plane. And what Crossplane provides? Providers. and composition is to create the uh, uh, resources into your AWS or Azure. Okay, I hope you are following this until now. Now let's say your Git remains same, your pipeline remains same. Now you are deploying to different regions. What we are going have to solve? Crossplane is again a CLI based. It is not a graphical user interface. So now developers to work on this, they need to understand crossplane. Of course, as a platform team, what I'm teaching here is for the DevOps people and who have to reskill to this platform to build this platform for their organization or for their team. But as a developer, you can't provide them the crossplane. You have to provide them the GUI, this part. So this part we going to explore backstage. So this part we explore crossplane. What is backstage? Okay. So let me continue this again in the next video. Little more on backstage and GUI. I will end this video with crossplane now, where in this architecture you see a control plane and which tool we can use for control plane is crossplane. Thank you guys. Hope it is useful to you.